Now let us to turn to the other rule for the implication game, or for the implication part of natural deduction. This is saying, this is called this is implication elimination rule. And in its basic form, it's saying that if we have derived some formula x, and we also have derived x implies y, from these two things we can derive y, or we can justify y. So it's a very logical rule. It's some kind of self-evident rule, but let me give some examples that shows how it works. So actually, I will do a combined example where we're using the implication elimination rule, but also using the introduction rule. So you see it sort of in combination. So suppose we have, let's say, this formula here. I think we might have lost a bracket here outside the screen. So this is how it looks like. Suppose we want to prove. We have to prove this. Well, it turns out that it is tautology. So for all the combinations of 8 combinations of A, B, and C, if you do a truth table, you realize it always evaluates to true. But now let's do a box proof. So we really reduce the problem to show that from this we can derive this. Okay, so we have an implication here, so it's like the same kind of heuristic principle from before. Instead of proving this, we reason that we must go from A to B implies C, and for the same reason we can draw a box here. We go from B to C. But now you notice that we can actually not justify. There's a gap in the proof still. While all of these things in the beginning of the boxes are assumptions, and all of these are implication introductions, we have a problem in justifying that line here. And this is where we need a new idea. That's where we need the other rule. We need the implication elimination rule. And the point here is really if we could prove A implies B at this stage, you can say it's like wishful thinking. Maybe at this stage we're just considering what would be nice to have proved. But if we could prove A implies B at this stage, then we could actually combine with line 1 and get the C, because you would have A implies B and you have C, so we could have combined with line 1. So it's a bit like in this stage we're using, you can say, wishful thinking. We hope everything will work out all right, but we can see that the only way forward, really, the only way to progress is to somehow, if we could prove A implies B here. And now it's automatic, because we want to justify A implies B. That's the same as showing that from assumption A we can derive B. And now actually the proof can be justified, because the only problematic step I haven't explained is this B here, but that can be justified because we already are inside a box where we have assumed B. So every single step can be justified. I'm not going to do the annotations. Here in this proof I'll use JAPE for that. Okay. So now we are in JAPE, and I want to derive the same thing, but in JAPE. So it's here working in JAPE is a bit deceptive, because on the one hand, JAPE often help you a bit on the way. So it's different from doing it with paper and pen. On the other hand, sometimes it's a bit difficult to find around in JAPE's menu system. So sometimes I certainly find that often when I can do things by hand, it's a bit more tricky to do in JAPE for other reasons. But let's look at it. The first step is clear. It's a backward introduction. This one is the same. We have an implication. We do a backward introduction. Backward introduction. But this is where you can see there's some dots here showing that we still have to justify the gap here. We still have to show how we can get from B to C. And that is where we need something new. We need to do the implication elimination. So I highlight these two formulas, and then I do an implication elimination. And lo and behold, you see they have found an implication elimination, but there's still something we haven't justified, which is correct, because we need to prove A implies B. But you can see we're in a very good shape, because we already assumed A, we assumed B, so certainly this should be true somehow. But the automatic thing to do is, because it's an implication, is to do an implication introduction, and then lo and behold, the proof is done now. So you can see there's no gap in the proof. The proof is justified. So this was an example where you saw how to use the implication elimination rule. It was used here.